Alright, this is our TED Talk. I'm Tommy Finnegan, and this is my cameraman, Jacob Tiernan. We're talking about amusement parks and how amusement park rides are actually engineered to amuse. There are a lot of engineering aspects behind amusement parks that normally we wouldn't know about or hear about, but we're basically going to talk about three main rides: the roller coaster, the water slides, and of course the bumper cars. The roller coasters they date back originally to the 16th or 17th century in Russia. The Russians made like up to 70-foot tall wooden slides covered in ice, which they used, and those eventually, over the years, became what we know as roller coasters. So how do roller coasters exactly work and get started and stop? Well, one popular method is the chain lift, which is a lifting mechanism made of chains that runs under the track and moves up hills like a conveyor belt. The chain lifts, the chains are fastened in a loop which is wound around a gear at the top of a hill and again at the bottom of the hill. At the bottom of the hill there's a motor which gets the cart moving, and after that it runs solely on momentum. There's no more motors after that. And the coaster actually grips to the chain with something called a chain dog, which is basically just a sturdy hook. But in more modern roller coasters, they've turned to something called a catapult launch lift, which is different than the chain lifts, because instead of dragging the train up a hill to build potential energy, which is what the chain lift does, the catapult lifts basically just build large amounts of kinetic energy in a short amount of time and then basically launches it. The catapult launch lift uses something called a linear induction motor, which builds two electromagnetic fields, and the motor pushes the fields, which causes the cart to move at a high speed. The advantages to the catapult launch lift are basically just that the speed, efficiency, durability, precision, and controllability. So that's why many roller coasters have turned to this technique. And what would a roller coaster be without brakes? Obviously you need brakes to stop the cart, but the thing about roller coasters is that the brakes are not actually on the cart, they're built into the track. So there are clamps built into the track that are used to stop the cars. These clamps are controlled by a central computer, which controls a hydraulic system which moves the clamps up and down in order to slow down and eventually stop the coaster. So there are 8 major types of roller coasters, but unfortunately we're not going to talk at all about them. But a couple of them include sit-down roller coasters, stand-up roller coasters, inverted roller coasters, and suspended roller coasters. That's just basically an idea of some of the designs behind them, but we talked enough about roller coasters. And onto water slides. Water slides can appear to look similar to the shape and design of roller coasters, but they actually use water, and they are made of fiberglass segments which are fastened together with heavy-duty bolts, and they have a framework of steel girders which are supported by cantilevers, and these are basically just the skeleton, and the structure of the water slide is basically just holds it up and makes sure it doesn't collapse. But a big part of the engineering behind water slides is how the water enters the slide and how the water is used. the water enters the slide through a pump, which turns a drive shaft, and the drive shaft is attached to a propeller which drives the water forward, similar to how an airplane propeller drives air particles forward. The pump is housed in a building below the slide. It's not actually connected to the slide, but the pump draws water from something called a collection sump, which is a pool at the base of the slide, and the pool or sump pushes water up through a narrow slide into the pump, which then turns the drive shaft and drives the water forward. And finally, we're going to talk about bumper cars. They're always a good ride to go on, but we don't know exactly how they work yet. But they run on electricity, of course. There's a wire grid on the ceiling of the ride, and the wire on the back of the car. As you know, you've probably been on them. You can see that the cars have kind of a wire that goes up to the top, and it moves along with the car. So the wire basically feeds electricity to the car, and the car changes electricity into kinetic energy, which enables the car to move. And of course, bumper cars, safety is a big issue, or a big kind of issue that designers and engineers take into consideration. There are, of course, seat belts included, which help to keep the passenger in place, and also around the car there are large rubber bumpers, hence the name bumper cars. But the bumpers basically prolong the impact and diffuse the force of collision. If you don't know what that means, it's basically just softening the blow, so when you come into contact with another car, you don't wreck the car, or the impact is not too big that it knocks you back too hard. But that's basically the safety behind the bumper cars. So that is all we have to talk about, and that is basically how amusement park rides are engineered to amuse.